In the previous section, we learned about creating a production plan that takes the overall quantity of a product and establishes a feasible rate of output over a planned horizon of 1 to 3 years. The next step is to take the production plan and create the master production schedule, also called the MPS. The MPS is a minimum range plan that's more detailed than the production plan. The MPS takes the data at the product family level from the production plan and breaks it down to the end item level. The end item is the item that is delivered to the customer. If we use our earlier bicycle example, what this means is that at this stage, the specific models of bicycles are identified, their quantities and completion dates. The 1,000 bicycles each month is now broken down as an example into 250 adult bicycles, 250 kids bicycles, and 500 high-end racing bicycles, each completed on specific dates each month. Each model of bicycle will have its own manufacturing schedule, which is the MPS, telling you the quantity of each being manufactured, along with a due date when the bicycles need to be completed in order to ship to the customer. So just to clarify again, in the production plan, we had a production rate of 1,000 bicycles per month. The 1,000 bicycles was referred to as the quantity at the product family level, as we did not need to know the specific types of bicycles. Now at the MPS level, we take the product family level and break it down to the end item level. The end item level is the specific types of bicycles that we need to make each month. It's important that this is understood before we move on. I'll see you in the next lesson. Let's apply what we've learned so far and create an MPS. Here we have a forecast of customer requirements of 30 units each period for 6 periods. On the second line, I'm introducing a planning tool called Projected Available Balance, PAB for short. I'm also going to introduce a formula. Ending PAB equals beginning PAB plus MPS receipt minus customer forecast. Using the formula, let's begin filling in the chart. We'll start with period 1. We have an opening inventory balance of 40 pieces. Using the formula for period 1, we have 40 pieces as the beginning PAB, plus 0 as we don't have an MPS receipt, minus the forecast of 30 equals balance of 10 as the ending PAB for period 1. Now we go to period 2. The ending PAB in period 1 is the beginning PAB in period 2. Using the formula, we have 10 pieces as the beginning PAB, plus 0 as we don't have an MPS receipt, minus the forecast of 30 equals balance of minus 20. Since we have a negative PAB, we need to schedule an MPS in period 2. Since the lot size is given at 50 units, we can run the formula again as follows. 10 pieces as the beginning PAB, plus 50 pieces for the MPS receipt, minus the forecast of 30 equals 30 as the ending PAB for period 2. Whenever you have a negative PAB, you must schedule an MPS. This is an important point, so let me say it again. Whenever you have a negative PAB, you must schedule an MPS receipt. Let's go to period 3. The ending PAB in period 2 is the beginning PAB in period 3. Using the formula, we have 30 pieces as the beginning PAB, plus 0 as we don't have an MPS receipt, minus the forecast of 30 equals ending PAB of 0 for period 3. Let's go to period 4. The ending PAB in period 3 is the beginning PAB in period 4. Using the formula, we have 0 pieces as the beginning PAB, plus 0 as we don't have an MPS receipt, minus the forecast of 30 equals balance of minus 30. Since we have a negative PAB, we need to schedule an MPS receipt in period 4 and run the formula again. 0 plus 50 minus 30 equals 20 pieces as the ending PAB for period 4. Let's go to period 5. The ending PAB in period 4 is the beginning PAB in period 5. Using the formula, we have 20 pieces as the beginning PAB, plus 0 as we don't have an MPS receipt, minus the forecast of 30 equals balance of minus 10. Since we have a negative PAB, we need to schedule an MPS receipt in period 5 and run the formula again. 20 plus 50 minus 30 equals 40 pieces as the ending PAB for period 5. Let's go to period 6. The ending PAB in period 5 is the beginning PAB in period 6. Using the formula, we have 40 pieces as the beginning PAB, plus 0 as we don't have an MPS receipt, minus the forecast of 30 equals balance of 10 pieces as the ending PAB for period 6. We're done, and that's it for projected available balance. Hopefully that wasn't too complicated. Again, keep in mind, I'm showing you manually so you can see and understand the steps and calculations. In the real world, these steps may be automated, and you're using some sort of software program that's doing the number crunching and telling you when the next MPS receipt is needed. And that's it for this exercise. If you have any questions, please let me know. Send me a note. RCCP Capacity Planning, RCCP for short, is a check on the resources needed to support the master production schedule. It deals with the need for capacity at the end item level. What this means is that it determines if resources will be available to meet the demand for capacity created by the MPS. It's also referred to as the second capacity check. The first check being resource requirements planning, which we discussed earlier. RCCP capacity planning validates the MPS in the same way that resource requirements planning validates the production plan. The key resources being checked once again is labor and equipment. Other key resources that need to be considered is material, warehouse space, capabilities at a critical supplier, to name a few. There's no point in ramping up your internal production and doubling your output if it needs to go out to a supplier for a critical operation and the supplier is unable to handle the increased volume since they weren't included in the capacity check and validation at the beginning. The validation process and calculations for RCCP capacity planning is similar to resource requirements planning, except with RCCP capacity planning, you're using weekly, not monthly time intervals, so in that respect, it's a more detailed level of capacity review. If it's identified through the RCCP capacity planning process that labor or equipment resources will not support the MPS, decisions and adjustments need to be made. Capacity can be increased in various ways, such as authorizing overtime, hiring more workers. Some of the work can be sent to an outside subcontractor. You can change the manufacturing process so that different equipment can be used, are a few options to be considered. Alternatively, the MPS can be changed and reduced as long as you get some agreement with the customers and your business can afford less sales and profit. Whatever the decision, it will have far-reaching effects for the company and the employees. It's important to analyze each option and make the best decision possible to maximize profit and benefits for the company. In this lesson, I'm introducing another planning tool called Available to Promise, ATP for short. ATP is defined as the uncommitted portion of a company's inventory and planning production, maintained by the supply chain expert to support customer order promising. Assume your business includes customers calling in daily, placing orders and needing a quick response to when they can get their items. This is where ATP comes in to have parts immediately available to satisfy this type of customer demand. We'll go through an example in the next lesson to demonstrate how ATP works. See you then. In this lesson, let's go through an exercise to understand ATP. Here we have a forecast of customer orders for the next 6 periods. On the second line, we have MPS receipts that have already been scheduled and will be available in those periods. Here's a very important rule about ATP. ATP is calculated for each period where an MPS receipt takes place, and it takes into account all customer orders until the next MPS receipt. Let me show you what this means. Mentally put in the following bars, as this will help you visualize which periods to use and when. Let's start with period 1. We have an MPS receipt of 35 pieces. We have a customer order for 20 pieces in period 1. Looking ahead, the next MPS receipt is in period 3, so this ATP needs to also include the customer order for period 2. So this is how the calculation works. 35 pieces MPS receipt in period 1, minus 20 pieces customer order for period 1, minus 10 pieces customer order for period 2 equals 5 pieces ATP in period 1. In the ATP line for period 1, put in 5. This means that in period 1, we'll have 5 pieces available to promise until the next MPS receipt in period 3. Let's go to period 3. We have an MPS receipt of 35 pieces. There's a customer order of 10 pieces in period 3. Looking ahead, the next MPS receipt is in period 5, so this ATP needs to also include the customer order for period 4. This is how the calculation works. For this exercise, let's assume that all ATP pieces from period 1 is consumed and nothing is carried over. You have 35 pieces MPS receipt in period 3, minus 10 pieces customer order for period 3, minus 10 pieces customer order for period 4, equals 15 pieces ATP in period 3. Therefore, in period 3, we have 15 pieces available to promise until the next MPS receipt in period 5. Let's go to period 5. We have an MPS receipt of 35 pieces. There's no customer order for period 5. Looking ahead, the next MPS receipt is beyond period 6, so this ATP needs to also include the customer order for period 6. The calculation works as follows. You have 35 pieces MPS receipt in period 5, minus 0 pieces customer order for period 5, minus 30 pieces customer order for period 6 equals 5 pieces ATP in period 5. In period 5, we'll have 5 pieces available to promise until the next MPS receipt. It may be a bit confusing at first, but once you visualize where the bars need to be, it definitely helps to understand how the calculation needs to work, and ATP becomes a lot less complicated. And that's it for ATP in this lesson. There's a couple of exercises left to complete in this section, and then we'll move on to another topic. It's time for another exercise. In this exercise, you'll be improving your skills by creating an MPS and using the projected available balance tool. Here we have forecast data over 6 periods. Your MPS lot size is 200 pieces, and your beginning inventory is 100 pieces. You'll be using the formula ending PAB equals beginning PAB plus scheduled MPS minus forecast. We're going to use the same rules as we did in the previous exercises. When I tell you to pause the video, pause it and begin the exercise. When you're ready to review the answers, resume the video and continue. Let's begin. Pause the video. Let's review the answers together. For period 1, we have an opening inventory balance of 100 pieces. Using the formula for period 1, we have 100 pieces as the beginning PAB, plus 0 as we don't have an MPS scheduled receipt, minus the forecast of 60 equals balance of 40 as the ending PAB for period 1. Now let's go to period 2. The ending PAB in period 1 is the beginning PAB in period 2. Using the formula, we have 40 pieces as the beginning PAB, plus 0 as we don't have an MPS scheduled receipt, minus the forecast of 130 equals balance of minus 90. Since we have a negative PAB, we need to schedule an MPS in period 2. Since the lot size is 200 pieces, we can run the formula again. 40 pieces as the beginning PAB, plus 200 pieces for the MPS receipt, minus the forecast of 130 equals 110 as the ending PAB for period 2. Remember, whenever you have a negative PAB, you must schedule an MPS. This is a very important point to remember. Here's the rest of the solution. Take a few minutes and review your answers. Pause the video if you need to. If you answer differently, you may want to review the earlier lessons in the course. If you're still stuck, send me a note. I'm here to help. That's it for this section. There's one more exercise to complete on your own, and then we'll move on to another topic. If you have any questions and need me to explain further, please send me a note. I'm here to help. Thank you, and thanks for watching. We're continuing to move from a high level of planning into a more detailed level of planning. In this section, we're going to learn about material requirements planning, MRP for short. MRP acts as a bridge between the MPS, which we learned in the last section, and the production activities on the shop floor. It's a short-range material plan. MRP relies on the use of planning application software to support the day-to-day management of the production activities and work. MRP uses the MPS for the quantities and due dates of the end items and creates a time phase plan that tells you what components and materials are needed to make an end item and when they're needed. If you're wondering what's time phasing, I'm going to discuss it later in this section and show you how it works. MRP creates what's called a priority plan that tells you when orders should be released into work, when materials purchased from suppliers need to be ordered and received, and when components need to be ready. It includes everything that's needed to complete the end item to support the due dates that MRP receives from the MPS. MRP focuses on scheduling the dependent demand items, so they'll be available in the quantities on the date the independent demand, which is the end item, is to be manufactured. Remember our earlier lesson on understanding the difference between dependent and independent demand. All this may sound confusing, but really it isn't. As we go through the next two sections, you'll gain a better and better understanding of MRP and how it works. As you can see, MRP is also one of the longer topics, so we'll be spending a lot more time and covering a lot more information, plus a few exercises as well. As we now get into more of the detailed scheduling, I'm going to be using various supply chain terms. I'll review a few of the more relevant terms in the next several lessons, which should help in your learning as we progress further in this section and the course. Let's start with the term work center. I used this term back in section 5 when we learned about the intermittent layout. If you recall, I mentioned grouping similar or like equipment or resources into work centers, such as lathes, drill presses, or saws. If I expand a little more on this, a work center usually represents a factory or manufacturing location. A work center location can include a single machine with an operator or group of same or similar machines which performs a specific task, such as milling, drilling, cutting, or it can represent a specialized shop, such as a paint shop or assembly shop, which consists of a crew of employees. As an example, here we have a manufacturing shop. I've highlighted a few of the work centers to give you an idea of what they can look like. A typical manufacturing facility would have many work center locations for all its various machines, equipment, and resources that are needed to manufacture a product. Even an external subcontractor would be assigned a work center location. Work is completed by being scheduled to the different work centers, and capacity calculations are based on each work center, taking into account the number of machines, the number of workers, and possibly the number of shifts. A bill of material, or BOM for short, is a listing of all the items that go into a top-level assembly or end item and shows the quantity of each. A bill of material is usually presented as a list. Here's an example of a summarized bill of material. The part on the top-level assembly, is the item that you're manufacturing. It's the independent demand item which you're forecasting or which the customer is ordering from you. In the MPS, it's referred to as the end item. In the production plan, it may be part of a family of parts. We also refer to this top-level assembly as the parent item in the bill of material. In this example, it's called ABC, which is sort of a part number or its designation when being ordered by a customer and when being manufactured. Down the left side is a listing of all the subcomponents that go into making ABC. Subcomponents can also be called assemblies, subassemblies, parts, components, raw materials. A lot of these names are used interchangeably. One person may say part, another may say component. One person calls it an assembly, another calls it a subassembly. Generically, they would all be called children of parent ABC. Subcomponents can be either manufactured internally or purchased from a vendor. Most importantly, as the supply chain expert, you must recognize them as the dependent demand items. They are linked to ABC, and their quantities required is calculated based on the demand for ABC. So let's go through the list and understand the different types of information being shown. You have assemblies, 2 of them. You have a manufactured part that you make in your shop. You have 2 purchased parts. You have raw material, 3 types that you purchase. For each subcomponent, the bill of material shows its part number, description, quantity that's required in the parent, and its unit of measure. There's a lot of useful information. However, In my opinion, this format lacks the relationship of the subcomponents to each other. As an example, it doesn't tell you what raw material goes into making what part. Let's go to the next lesson. We'll review another format for the bill of material. Here we have the same bill of material from the previous lesson, but it's displayed differently, which is called a product tree format. If you're familiar with a bill of material, I would assume it would be this format. I made it a bit colorful on purpose to color code and highlight the different components and subcomponents that make up a bill of material. The color coding isn't usually required, and I'm only doing it for this lesson. From this bill of material, you can see that on the top level, which we call level 0, you have the parent part or the end item. On the next level, which is level 1, we're told that in order to make the parent part, we need assembly number 1 and assembly number 2. On level 2, we're told that in order to make assembly number 2, we need raw material number 3 and purchase part number 2. We're also told that in order to make assembly number 1, we need purchase part number 1 and a manufactured part. On level 3, we're told in order to make the manufactured part, we need raw material number 1 and raw material number 2. Notice that the parent part, as we now know, is referred to as the independent demand. This is the demand we receive from the customer as an order, or that we forecast in place of an actual order. All the remaining components below the independent demand item are referred to as dependent demand items. As we learned earlier, dependent demand is demand that is related to the demand for another product. It's calculated based on the demand for the independent product. I know I've said this already, but it's an important point worth repeating. In this lesson, we're going to learn about lead time. Lead time is defined as a span of time required to perform a process. By itself, that may not hold a lot of meaning, but when you combine lead time with the bill of material that we learned in the previous lesson, you can begin to understand and appreciate how long a part will take to be manufactured. Customers will often want you to reduce your lead times. They want the parts when they need them, not when you can supply them. Remember the list of customer expectations that we covered earlier. This was on the list under speed. Manufacturers also strive to reduce their lead times, partly to satisfy customers, but also for their own financial gain. Long lead times translates to more work in process, which is inventory of unfinished products, and can amount to a very large financial investment. The shorter the lead times, the faster the product is produced and sold and payment received in, or to pay for more materials to be bought to produce more product. It's a continuous cycle and it needs cash flow to keep it running. I think the finance and accounting people will agree. As a supply chain expert, your responsibilities may not encompass all the financial aspects, but it's still good to know the impacts of changing lead times, especially when an increase is being considered. Lead time has 5 elements. First is Q, which is the time spent waiting for the operation to begin. This is the time a part is sitting at the operation, waiting for the current part to be completed. Q is usually the longest element, and in my opinion, the greatest opportunity to reduce. Second is setup, which is the time spent getting ready to do an operation. This can include preparing tooling, preparing the work instructions, loading material. Third is run, which is the time spent performing an operation. Fourth is wait, which is the time spent waiting after the operation ends. This is the time the part sits after the operation has been completed, waiting to be moved to the next operation. And finally, move, which is the time spent physically moving the part between operations. Lead times are typically established and firmed up for each component when it's initially introduced into manufacturing. Lead times should be reviewed regularly. It's not a one-time exercise. You need to make sure lead times are being achieved. Otherwise, your scheduling will always be off, and so will your capacity calculation. From time to time, adjustments may need to be made, upwards or downwards as needed. Understanding part numbers is our next lesson. If you've ever bought an item that needed to be assembled, you most likely came across the term part number while reviewing the assembly instructions. In simple terms, a part number is typically a series of numbers or letters or both that acts as a unique identifier for an item. Instead of referring to an item by a name, you use a part number. Part numbers are widely used in any type of manufacturing environment. Alternate names for part number are item number, product number, stock code, stock number, stock keeping unit, to name a few. I personally prefer part number. A simple part number can be any combination of number or letter characters. The overall number of characters or length of the part number depends on the complexity that the organization needs or desires. Companies may assign a specific department or function in the organization to create and manage part numbers. Certain rules should be applied when creating and assigning part numbers. My list is by no means every rule out there, and companies are free to come up with their own rules. I'm simply highlighting a few that should be considered, and in my opinion are important. Every item should have a part number. In our case, every item on the bill of material should have a part number assigned to it, from the end item on the top to the lowest level subcomponent at the bottom. Every part number must be unique, and no two items should have the same part number. If you ever had to follow instructions when putting something together, you definitely don't want a couple of the items having the same part number. That can be very confusing. The instructions are typically not well written to begin with, so the last thing you need is having different items with the same part number. Part numbers within an organization should follow a common format. What this means is that if a company has decided to use an 8-character part number with a dash after the third character, and the last character must be an alphanumeric character, then every one of their part numbers should have the same format. This simply prevents confusion and adds a level of error prevention. If you come across a part number with 7 characters, you automatically know that a character is missing. When an item is no longer in use, its part number should be discontinued, and discontinued part numbers should never be reused or reassigned to another item. I'm not sure if that would be acceptable in any industry, as you lose control over what you're building, referred to as configuration control. I welcome your feedback on this, if there are legitimate cases where this is acceptable. We haven't discussed it yet, but will later on in this course, and that's inventory management. And control of inventory in a manufacturing environment is by unique part number. So you definitely need to follow some rules with part numbers if you want to manage your inventory properly. Now that we learned a few new terms, let's get back to discussing MRP and seeing how these terms fit in and get used. There are many MRP software applications available on the market. Some programs are very complex, very costly, others not so much. I'm not going to critique different MRP systems or tell you which one is better than the other. What you need to know and what's important right now is that in order for any MRP system to function properly, it needs information in order to do its job. Let's review the main inputs that MRP needs. First, MRP needs the master production schedule. We learned about the MPS in the last section. The MPS provides the schedule for the end items, the quantities for each end item, and their due dates, which is when the customer wants it. Second, MRP needs the bill of material for each end item, which provides the product structure and how to build the end item, and the quantity of each subcomponent to build the end item. Third, MRP needs the inventory status of all the subcomponents, so that excess material is not being ordered or built, and to make sure enough is available to build the number of end items needed. And lastly, MRP needs planning factors. This includes the lead times for each subcomponent. Another relevant planning factor may be a scrap factor if you have a process that's susceptible to scrap. This will allow MRP to schedule additional pieces of the subcomponent to which the scrap factor is applied. If the subcomponent is scrapped, the extra pieces would be used as a replacement and thereby prevent any delay or impact to delivering the end item on schedule. Safety stock is another planning factor that you can apply to raw material if there's uncertainty in the supply from the vendor. You can choose to order extra pieces and hold them in inventory to be used when the vendor is late. This will minimize any delays to your production. It's a decision for management to carry additional inventory, as they'll need to answer for it. As a supply chain expert, you would recommend appropriate planning factors to be used. In this exercise, we're going to create a bill of material. We're given the following data. Item A needs 3 item Bs, 3 Hs, and 2 Js. Item B needs 2 item C's and 1 D. Item C needs 2 item E's, 4 F's, and 4 G's. Item H needs 2 item G's and an I. First, we need to determine the parent item. We need to look at each relationship. B goes into A, so B isn't a parent. C goes into B, so C isn't a parent. H also goes into A, so H isn't the parent. Since we eliminated the others, by default, A must be the parent. But equally, A doesn't go into anything, so this is a check and confirmation that it's the parent item. Now that we know the parent item, we start with A. To build A, you need 3 B's, 3 H's, and 2 J's. To build B, you need 2 C's and 1 D. To build C, you need 2 E's, 4 F's, and 4 G's. And to build H, you need 2 G's and an I. And there you have the bill of material. I think that was pretty straightforward. Now let's answer the question on how many G's do you need to make 1A. If you look at the bill of material, G is used in 2 places. It's used to make item C on the left side of the tree and to make item H on the right side of the tree. Let's start on the left side. You need 4 G's to make a C. You need 2 C's to make a B, and you need 3 B's to make an A. So how many G's do you need on the left side? You need to multiply 4 times 2 times 3 equals 24. You need 24 G's. Now on the right side, you need 2 G's to make an H, and you need 3 H's to make an A. You need to multiply 2 times 3 equals 6. You need 6 G's on the right side. Then add 24 and 6 equals 30. In total, you need 30 G's to make 1A. If that's not making sense, you may want to review this lesson again. Thankfully, the MRP application software takes care of these types of calculations for you, so you don't have to do them manually. But as a supply chain expert, it's good to have the skills and know how it works. If you have any questions and need me to explain further, please send me a note. I'm here to help. Thank you, and thanks for watching. As we learned in the previous section, lead time is defined as the time it takes to perform a process or make a part. It's also the length of time to place an order with a vendor and receive a purchased part. Now I'd like to introduce a couple more powerful MRP features. The first is offsetting, which is the process of calculating when an order is to be released into work. It makes use of a subcomponent's lead time in calculating when an order should be released and completed. The second is exploding, which is the process of determining the total quantity of each bill of material item needed to make the parent item. A good example of exploding was the previous lesson when we had to calculate the total number of G's that were needed to make item A. With this added information, MRP is now able to do its main function, which is to provide a time phase schedule for a future demand. If you remember, I previously mentioned time phasing and said we'll be coming back to it. Next lesson, we'll go through an example and see how time phasing works. I'll see you then. Here we have our famous bicycle that I've been talking about since the beginning of this course. I don't have all the components shown, but most of the major components are here, and this is enough for this exercise. We see from the summarized bill of material various subcomponents that make up the build of this bicycle. We have a couple of assemblies for the frame and the handlebars, the bicycle forks, the tires, handlebars and grips, the bike's frame, its seat, and chain. We also have various tube material for the frame, the forks, and the handlebars. We also know the quantities required for each. If you notice, for the unit of measure, the tube material will be ordered in feet and not a quantity of, as the rest of the subcomponents. In the product tree format, we now have an understanding of the relationship of the subcomponents to each other, but most importantly, we have the lead times for each subcomponent, whether purchased or being built. I'm still using the color coding to highlight the different types of subcomponents. The assemblies are in green, the manufactured parts are in brown, the purchased parts are in blue, and the purchased tube material is in red. You can also see the lead times for the purchased items are much higher than the rest. This is the first sign that purchase orders will need to be issued to vendors well in advance of beginning any manufacturing. Here we have our bill of material for the bicycle again. As you can see, I turned it on its side. This is only for demonstration purposes, to show how MRP does its calculations. As a supply chain expert, you would be relying on your MRP software instead of doing it manually. But you still need to know the concepts, the calculations, and be able to verify that the output from the software is correct. The software is just a tool. It's not the supply chain expert. You are. In this example, I've also adjusted the size and length of each box to roughly represent its lead time. As a visual, it gives a reasonable amount of time to complete each task. Again, for the purposes of this example, I'm going to use numbers instead of calendar days. Let me explain what I mean. Assume you receive an order for one bicycle, and the customer wants to receive it in 20 days from today. Let's identify today as day 0, and the day when the bicycle needs to be completed as day 20. In your MRP software, day 20 is scheduled as the due date for the end item, which is the bicycle. MRP then does its job of time phasing and will come up with a schedule as follows. Per the bill of material, the end item, the bicycle, has a lead time of 1 day. It has a due date of day 20, and based on the lead time, its order start date is offset by 1 day. MRP schedules the order start for day 19. The handlebar assembly goes into the bicycle, therefore its due date is set for day 19. Based on its lead time, its order start date is offset by 1 day. MRP schedules the order start for day 18. The handlebar goes into the handlebar assembly, therefore its due date is set for day 18. Based on its lead time, its order start date is offset by 1 day. MRP schedules the order start for day 17. The handlebar grips goes into the handlebar assembly, therefore its due date is also set for day 18. Based on its lead time, its order start date is offset by 4 days. MRP schedules the order start for day 14. The 1-inch tube material goes into the handlebar, therefore its due date is set at day 17. Based on its lead time, its order start date is offset by 12 days. MRP schedules the order start for day 5. And here are the other start dates scheduled by MRP. As you can see, the first order will need to be released on day 4 for the purchase of the tires, which has a lead time of 15 days and needs to be available by day 19. On the following day, on day 5, an order to purchase the 1-inch tube material will need to be issued, and so on for the rest of the orders. In combination with the offsetting to determine the start and completion dates of all the subcomponents, MRP is also exploding the requirements. This means that if the customer is ordering 2 bicycles, MRP is calculating that 2 handlebar assemblies is needed, which requires 2 handlebars, 4 handlebar grips, and 2 feet times 2, which is 4 feet of the 1-inch diameter tube material, and so on for the rest of the bill of material. Once the full requirements are exploded and the quantities of each subcomponent is determined, MRP checks inventory levels. Any available inventory would be used before buying more material or manufacturing more components. You may be wondering, why would there be inventory available? Could be for a number of reasons. You may have scrap factors or safety stock factors built in for certain subcomponents. Tube material, which may not be that costly, can be purchased in bulk to get lower pricing and held in inventory to be used when needed. The handlebar grips could also be purchased in bulk. Certain subcomponents may be manufactured in batches to lower labor costs, which could leave a few in inventory at any given time. The company may also choose to hold a certain amount of inventory in order to quickly react to customer orders and improve delivery times. Some customers always expect an expedited level of service. Despite all these reasons why you may have inventory, if you let MRP do its job and you execute the plans as laid out, MRP will manage your inventory for you and keep it to a minimum. I hope I didn't confuse you with the last exercise. It can get a bit complicated, but thankfully that's why MRP software should be used to manage it. Let's do another example. This is an important topic, so we need to practice. Here I have a simple bill of material. Item A is the parent item, and items B, C, D, and E are the subcomponents. In this exercise, we'll be scheduling the periods in which orders will be started and completed for each of the items. For this example, we're referring to the starts and completions as releases and receipts. The goal is to have 100 pieces of item A completed in period 5. Let's now complete the schedule for all the items. In order to have 100 pieces of item A available in week 5, MRP schedules a receipt of 100 pieces of item A in week 5. Based on its lead time of 1 week, an order release for 100 pieces is scheduled by MRP for week 4. According to the bill of material, item B and C must be available to make item A. MRP will schedule an order receipt for 100 pieces of item B and 100 pieces of item C in week 4. Based on item B's lead time of 1 week, an order release for 100 pieces is scheduled by MRP in week 3. Based on item C's lead time of 2 weeks, an order release for 100 pieces is scheduled by MRP in week 2. According to the bill of material, item D and E must be available to make item C. MRP will schedule an order receipt of 100 pieces of item D and 100 pieces of item E in week 2. Based on item D and E's lead time of 1 week, an order release for 100 pieces of each is scheduled by MRP in week 1. And there you have it. This is how MRP works. I hope that between both these examples, you have a better understanding. And keep in mind, even though the MRP software is generating the dates, it's just a tool. As the supply chain expert, you need to understand how those dates are being planned and that the plan makes sense. Next exercise you'll be doing on your own. So if you have any questions on either of these practice examples, please send me a note. It's time for another exercise on your own to see what you've learned. In this exercise, you'll be creating a time phase schedule that yields 200 pieces of item A in week 6. As a small hint, make sure you carefully review the bill of material, the lead times for each item, and especially the quantities that are required. We'll review the solution afterwards. We're going to use the same rules as we did in the previous exercises. When I tell you to pause the video, pause it and begin the exercise. When you're ready to review the answers, resume the video and continue. Let's begin. Pause the video. Let's review the solution and see how you did. In order to have 200 pieces of item A available in week 6, MRP needs to schedule a receipt of 200 pieces of item A in week 6. Based on its lead time of 1 week, MRP needs to schedule an order release of 200 pieces in week 5. According to the bill of material, item B and E must be available to make item A. MRP needs to schedule an order receipt of 200 pieces of item B and 200 pieces of item E in week 5. Based on item B's lead time of 1 week, MRP needs to schedule an order release of 200 pieces in week 4. Based on item E's lead time of 2 weeks, MRP needs to schedule an order release of 200 pieces in week 3. Here's the rest of the solution. Take your time and review the solution. Make sure you understand how the schedule is being calculated. Review the earlier lessons if you have to. If you're still having trouble, send me a note. I'm here to help. That's it for now. I'll see you in the next lesson. If you look at the complexities we discussed in the last few lessons, it's not something you can do manually. Bill of materials will get a lot more complex, multiple levels of manufacturing, and many subcomponents. If your business manufactures and sells many end items, or even hundreds, you're dealing with hundreds of bills of material, and many more hundreds or possibly thousands of subcomponents. You need MRP software to keep track and manage it all. I recommend that a company uses MRP software, but I'm not going to recommend on what software to buy. That's a business decision for each company. There are many MRP software applications available, and companies can buy off the shelf. They can customize to their needs or they can develop their own. The benefits are quickly realized. Every MRP software application will perform 2 major functions. First, it will perform lead time offsetting, explosion calculations, and the inventory calculations. Second, it will create action and exception messages. These messages are critical to the operation of MRP. An action message is created by MRP when it's time to issue an order. An exception message is created by MRP when there's a discrepancy. In both cases, an external action needs to take place to address the messages in order for MRP to function properly. It should be noted that MRP is not programmed to issue or release orders. This is required by external action, such as a scheduler working in the company, who will physically release an order to begin work in the manufacturing shop, or issue an order to purchasing to go buy a part or material from a vendor. An example of an exception message could be to expedite or de-expedite a schedule for a subcomponent, change a quantity on an order, cancel an order, to name a few. Before we move on, let me explain the different types of orders. First is a planned order. This is an order that's created by the MRP software to satisfy demand. It's under the control of the MRP software and subject to change whenever MRP regenerates, which can be daily or weekly, depending on the volume of activities. Regenerating MRP refers to a data update to take into account the activities that have taken place since the last regeneration. These updates are necessary for MRP to function properly, as they take into account new orders for end items that have been entered, subcomponents that may have been scrapped, excess inventory, delays with subcomponents, etc. MRP regeneration is typically scheduled after normal business hours. Second is a released order. This is an order that has been issued into work and is no longer considered planned. It's no longer under the control of MRP. Instead, it's under the control of the scheduler. It's also referred to as an open order, and it's the authorization for manufacturing to begin making a component or for purchasing to go buy material. The open order is released by the scheduler in response to an action message from the MRP system. And third is a firm planned order. This is unique in that it's a tool that allows a scheduler to override an order's MRP logic, which will prevent an order from changing whenever MRP regenerates. This starts as a planned order controlled by MRP. The scheduler then overrides the MRP dates, and at this point, the order is no longer controlled by MRP and becomes the responsibility of the scheduler to manage until the order is released and becomes an open order. I'll see you in the next lesson. Customers don't always know what they want until it's too late. This can be due to a variety of reasons. Perhaps they're simply reacting to changes from their customer in turn. Whatever the reason, the outcome is the same in that you, as the supply chain expert, are faced with a last-minute request to change the schedule. The change could be to pull in dates, push out dates, to add quantities, or reduce quantities. Maybe it's to cancel the entire order. Hopefully not, but it does happen. It happened to me. We're a few weeks away from delivering an order and the customer says he doesn't need it anymore. These situations need to be managed to limit your risk and avoid the cost impacts. Time fences are used to manage schedules and to deal with situations such as changes with customer demands or problems that arise when vendors are late or machine breakdowns. There's 3 important points to make note of. First is the liquid zone. It's a point in time that's beyond the planning time fence. This means that it's a point in the future outside of the lead time of the end item. There's no open orders to deal with, which means there's no physical activity that started. All the orders are still in the planning stage. And as we learned from the previous lesson, the orders are controlled by MRP. Since the orders are in the planning stage, making changes to the schedule is very easy and is a matter of updating the information in the MRP software application, and the changes are reflected in the planned orders after MRP regenerates. Second is the slushy zone. It's a point in time between the demand time fence and planning time fence. This means that there are open orders. Material has been ordered and subcomponents may be in work. Making changes to the schedule, increasing or decreasing quantities is possible, but will require manual intervention by the scheduler. It may require expediting or de-expediting certain orders. It may require canceling material and possibly having to pay for activities already started at your vendor. As much as satisfying the customer is important, you still have to make decisions that are best for your company. So make sure that whatever changes you do make or accept do not leave your company at risk. Situations tend to get complicated when there are added costs, and the customer is unwilling to accept paying more. And third is the frozen zone. It's a point in time that's inside the demand time fence. This means that you're well within the lead time of the end item. Material has arrived and manufacturing capacity has already been scheduled. Since the material and capacity has been committed to specific orders, any changes will have drastic consequences. It will act as a ripple effect and cause other orders to be impacted and possibly delayed. Schedule changes at this stage should be made at the senior management level, as there will be financial consequences, such as added costs to make the change, delayed sales on other orders, and possibly dissatisfied customers, since they will not get their order on time. Situations can get difficult to manage, as you may end up helping one customer at the expense of another. My suggestion: look at every request on a case-by-case basis. Look at the pros and cons and make your decision. If you have any questions and need me to explain further, please send me a note. I'm here to help. Thank you, and thanks for watching. Capacity Requirements Planning, CRP, is a check on the feasibility of the Material Requirements Plan, MRP, which we learned in the previous lessons. It deals with the need for capacity at the detailed production level. It determines in detail the amount of labor and equipment resources needed to support the production requirements. It's also referred to as the third capacity check. The first check being Resource Requirements Planning, and the second being Rough Cut Capacity Planning. Even though Resource Requirements Planning and Rough Cut Capacity Planning may indicate capacity is available and sufficient to support the production rates and the MPS, Capacity Requirements Planning may show that capacity is insufficient during specific time periods. This level of capacity deals with weekly and daily time intervals. Of all three levels of capacity planning, CRP is the most detailed. I'll see you in the next lesson, where we'll get into more specifics of how CRP works. Capacity Requirements Planning often requires application software that will analyze the workload of all the items that need to be manufactured: end items, components, subcomponents, parts, details, against the available resources and equipment at the weekly and even daily time periods. At this stage, each item has a specific schedule with a start date and completion date. Every operation in the build of that item also has its own start and completion dates. Based on this level of information, CRP is able to determine the level of workload that's required to be completed for each resource for each time period, whether daily or weekly. Inputting the data and the correct information is critical. Otherwise, garbage in, garbage out, as the saying goes. In the next lesson, we'll go over some of the inputs that need to be calculated accurately and maintained regularly in order that the entire system perform correctly and the company is getting the best information in order to make sound business decisions. I'll see you in the next lesson. As you should know by now, capacity refers to the capability of a worker or machine to complete a certain amount of output in a given time period. Resource Requirements Planning and Rough Cut Capacity Planning would typically use monthly time periods, while Capacity Requirements Planning uses weekly and daily time periods. In order to be able to calculate capacity, you need to understand available time, utilization, and efficiency. Let's go through an example of each. If a manufacturing department in a company has 5 machines that work 8 hours a day and 5 days a week, what's the available time of that department? We're going to use the formula available time in hours equals the number of machines times the number of hours per day times the number of days per week. We have 5 machines times 8 hours a day times 5 days a week equals 200 hours per week. The available time for the department is 200 hours per week. Let's make a couple of changes to the question and run the calculation again. The company receives a new contract, and the department buys a new machine and adds a second shift. What's the new available time? We now have 6 machines times 2 shifts, which is 16 hours per day, times 5 days per week equals 480 hours per week. The available time for the department has increased to 480 hours per week. Next, we have utilization. Utilization refers to the number of hours actually worked in a department in a given time period, compared to the amount of available hours in the department in the same time period, expressed as a percent. If a department is available for 200 hours per week, but the hours actually worked is only 150 hours, what's the utilization of the department? We're going to use the formula utilization equals Hours actually worked divided by available hours times 100%. The answer is 150 divided by 200 times 100% equals 75%. Utilization for the department is 75%. If you're wondering, why did the department only work 150 hours when 200 hours were available? There could be many reasons. There could have been a machine breakdown that took a couple of days to repair. Maybe there was absenteeism. A worker was sick. Maybe material was not available to start a job. The raw material vendor was late. These are the types of issues that will come up all the time that will impact your capacity plans and your schedules. As a supply chain expert, you'll be expected to know these issues, deal with them, and come up with plans that still support the customer needs. And lastly, there's efficiency. Efficiency refers to the actual output in hours compared to the standard output in hours expressed as a percent. As an example, if a department has an output of 250 standard hours for the week and actually worked 200 hours, what's the efficiency? Using the formula, efficiency equals standard hours of work divided by hours actually worked times 100%. The answer is 250 divided by 200 times 100% equals 125%. Efficiency for the department is 125%. If you're not familiar with efficiency, it deals with a level of performance. You may have heard people say, you need to be efficient. We need to work efficiently. In many cases, there's various ways to do something, the right way and the wrong way. Both will still get you to the end result, but the right way may be a lot faster with a lot less effort, while the wrong way will take a lot longer and a lot more effort. In manufacturing, standard times are assigned to tasks that will typically represent the time needed by an average employee. Efficiency then compares the actual performance to the standard. Now that we have a better understanding of available time, utilization, and efficiency, let's put all three together. When you do that, you can calculate what's called rated capacity. Rated capacity refers to the output that can be expected from a resource, such as a department, machine, or worker. Let's go through an example to show you how rated capacity is calculated. We'll use the same data from the earlier examples in this lesson. Available time equals 200 hours per week. Utilization equals 75%, and efficiency equals 125%. And we use the formula rated capacity equals available time times utilization times efficiency. Substituting with the data, you get 200 hours per week times 75% times 125% equals 187.5 or 188 hours per week. The rated capacity of the resource is 188 hours per week. And that's it for this lesson. We're coming to the end of this section, and now it's time to do an exercise on your own to see what you've learned. In this exercise, you'll be calculating rated capacity, but before you can calculate it, you'll have to do a couple of interim calculations based on the examples in the last lesson. That's my hint to you. Good luck. We're going to use the same rules as we did in the previous exercises. When I tell you to pause the video, pause it and begin the exercise. When you're ready to review the answers, resume the video and continue. Let's begin. Pause the video. Let's review the solution and see how you did. First, we need to calculate the available time. There's 4 machines that work 8 hours a day and 6 days a week. So the calculation is 4 times 8 times 6 equals 192 hours per week. Next, we're told the department only worked 144 hours. With this information, we can calculate the utilization as 144 divided by 192 times 100% equals 75%. Now we have all the parts to calculate rated capacity. The calculation is 192 times 75% for the utilization times 115% for the efficiency equals, rounded up, 166 hours. If you have any questions and need me to explain further, please send me a note. I'm here to help. Thank you, and thanks for watching. Up to now, we've been going through the various stages of scheduling and planning. We learned about creating a production plan and setting production rates. which takes place at the sales and operations planning stage. Then we learned about the master production schedule. It uses the data from the production plan and breaks it down into individual items and their due dates. We then learned about material requirements planning, which uses the data from the master production schedule and through time phasing tells you what components and materials are needed to make an end item and when they're needed. We also looked at a capacity review at each stage as a check to make sure resources such as labor, equipment, technology are available to support the plans. We now need to look at the execution phase, which is production activity control, or PAC for short. PAC executes the master production schedule and the material requirements plan. It makes sure resources are being used optimally. It minimizes the work in process and ensures the customer service is maintained by completing products on schedule so the customers receive their orders on time. Let's go over some of the specifics that production activity control manages. It makes sure that resources such as labor and machines are ready when they're needed. It provides a further detail level scheduling at the machine level or the resource level. It releases orders to begin manufacturing. It ensures orders are being completed in the proper sequence and that the priority of each order is maintained. It monitors the work in process, the lead times, and the queues at each resource or machine. PAC tracks the production level, the output, and whether the plans are being executed on schedule, and if not, what actions are happening to get back on schedule. PAC makes sure that plans are doable, that they can be achieved. If plans can't be achieved, PAC will then take steps to make changes to improve the plans, such as coordinating overtime or even adding more resources. PAC is continuously interacting with manufacturing and scheduling. They are conveying information and providing feedback. They're making sure that everyone is on the same page and that everyone is working to the same plan. Automation can play a major role in supporting PAC activities. One of the tools that production activity control can use is a report called a dispatch list. The dispatch list gets generated daily and shows the open orders listed by work center in priority sequence. This listing basically tells the operations folks and machine operators the order in which the jobs need to be completed. It's a very good tool to maintain priorities and keep on schedule, as long as you follow what the dispatch list is telling you. I'll see you in the next lesson. Here's a typical process flow that production activity control may follow when releasing orders to begin manufacturing. This is an example only. Companies should have something similar that they follow. It doesn't make sense to release an order and at the first operation it's discovered that something is missing. The whole point is to do the checks and balances beforehand, and when the order does get released, manufacturing begins on time. If you start on time, you have the best chance of finishing on time, and your schedule is maintained. Let's have a look at the process. Before the order is given the go-ahead, there's an initial check to make sure that material and tooling has been prepared and is available. This is very generic. Depending on your business and your products, your check may involve other things. Maybe you have a formal checklist that you go through. Whatever it is that you're checking, if anything is missing, the order shouldn't proceed further until everything you need is available. At that point, the order is ready to be launched. The next check is on the capacity and the availability of the resources. If the resource is a critical machine that broke down earlier, there may be a bottleneck or a backlog. If production activity control is doing its job, they should already be addressing it. They should be communicating with manufacturing on working overtime once the machine is back up and running. They should also be talking with scheduling to see if the schedule can be adjusted. Maybe there's an option to use another machine. So engineering or whoever looks after setting the manufacturing process may also be involved. If there's absenteeism and the worker is off, again, production activity control should be going through the alternatives and talking with the various departments to make up the lost time. Once the capacity and resources are confirmed, the order is released and production activity control moves on to the next order. And that's it for production activity control. If you have any questions and need me to explain further, please send me a note. I'm here to help. Thank you and thanks for watching. I've mentioned inventory a few times in the course already. In this section, I'm going to expand on the topic and we're going to learn a lot more about inventory. Inventory takes on various forms. It's the raw material that you've purchased and have on hand to manufacture your products. When it enters production, it's recorded as work in process, which is the raw material being manufactured and transformed into your finished product. And it's the finished products that you've completed, not yet sold to a customer. Each of these three forms of inventory have a value of cost associated with them, and the finished product obviously having the highest cost. Another category of inventory is known as MRO. MRO stands for maintenance, repair, and operating supplies. These items support the manufacturing activities and include spare parts for the equipment, lubricants, consumables, etc., to name a few. They say a picture is worth 1,000 words. Here we have inventory, boxes and boxes as far as the eye can see, and piled high to the ceiling. Why do we carry so much inventory? Well, organizations are faced with a lot of uncertainty, and the uncertainty is managed by carrying inventory. Organizations are challenged in understanding how much customers will buy and when they'll buy it. Remember, customers buy when they want to buy, according to their schedule, and they expect that it will be on the shelf waiting for them when they're ready to buy. Inventory is a very large financial investment. For those of you with accounting or finance backgrounds, you all know that inventory is a current asset on the balance sheet and an expense on the income statement. Reducing inventory reduces the asset base and corresponding variable expenses, which has a positive impact on the return of assets, which is a key financial metric for many organizations. The other benefit of inventory reduction worth mentioning is that inventory carrying costs are reduced. As inventory turns are increased, there is less capital tied into inventory and more is available for other needs in the organization. As a supply chain expert, your decisions have a direct impact on inventory. You decide when to buy and how much to buy, whether it's raw material or purchased parts and components. You also control the manufacturing schedule and when subcomponents and end items need to be started and completed. I'm not suggesting that the full burden is on your shoulders. Your organization will need to have procedures and policies to follow when it comes to inventory. Your management doesn't want you to buy 100 pieces of something in order to get the lowest price if it will take years to use it up. There will need to be a balance, and it will be up to you to establish that balance. The rest of this section should help. I'll see you in the next lesson. Customer service can be viewed as anything that comes into contact or touches the customer. It can be a commitment or a mission from an organization to providing customer satisfaction. It can be a performance measure, such as on-time deliveries or an order fill rate. It can be a task that must be performed to satisfy a customer's order, such as processing an order, invoicing, returns, and claims. Organizations should use all three forms of customer service in their internal processes. When looking to improve customer service, questions begin to arise. Why improve it? Why not to improve it? Is 100% achievable or impractical? How to improve it? And what's the cost to improve? An organization can decide to ship its product by air to improve lead times and delivery. They can choose to carry safety stock, which is also known as buffer. Simply put, safety stock is nothing more than having extra parts in inventory to protect against the uncertainty in the supply and demand and to prevent stockouts. A stockout being a situation of running out of inventory. Each of these decisions, shipping by air or carrying more inventory, is an added cost. In order to recognize an improvement in customer service will require some level of investment, such as increased transportation costs or higher inventories. There's a strong assumption that for every improvement in customer service, there's an increase in revenue. At some point, as the service level and the cost to improve the service level continues to increase, the revenue gained from the increased service level begins to decrease. Eventually, the cost of service will far outweigh the revenue gained from that service. As an example, you're a manufacturer and your current customer service level is 90%. Through internal reorganization, establishing new procedures, and employee training, you're able to increase your service level to 95%. The cost for every % increase in the service level is minimal compared to the revenue gain. At this point, the manufacturer decides they want to continue increasing the service level. Having exhausted low-cost improvements, the easy fixes, the manufacturer now faces decisions that will be a lot more costly. To further increase the service level may require carrying a lot more inventory, which the manufacturer agrees to do and increases the inventory by 25%. The service level also increases to 97%. The manufacturer is pleased with the revenue gains. However, the cost to increase the service level from 95 to 97% was far higher than the cost to increase it from 90 to 95%. The manufacturer now sets his sights on reaching 99% or even 100%. The manufacturer's team determines that it will require a restructuring of the entire company, plus having the latest technological advances on the market. The investment will be considerable and will outweigh whatever revenue gains can be further achieved by reaching a 99% or even 100% service level. Should the manufacturer proceed with the investment? Give it some thought. What would you do if it was your company? My answer is no. I wouldn't do the added investment, as the cost far outweighs the added gains. That's my opinion. Besides, achieving 97% is a huge improvement and accomplishment. The company should be proud of that, and their efforts should be towards maintaining it. I'll see you in the next lesson. A stockout occurs when a demand cannot be satisfied. The finished goods aren't available when or where a customer needs them. Stockouts can occur due to various reasons. They can be caused by demand that exceeds the available inventory, and customer orders can't be filled on time. Stockouts are also caused by production problems that lowers the manufacturing output of finished goods, and by supplier problems that delays the delivery of material or purchase parts, causing delays in the manufacturing of finished goods. Whenever the seller is unable to satisfy the customer's demand, any one of four events can occur. First, the customer will wait until the product is available. Second, a back order is created for the customer, which highlights a demand was missed that still needs to be filled. Third, the customer is dissatisfied and goes elsewhere, and the seller loses the sale to an alternate product. And fourth, the seller loses the customer and all future sales. The customer is so dissatisfied and upset that he or she will not return. The cost of a stockout is difficult to calculate, as it includes the cost of a back order, cost of lost sales, and the cost of lost customers and future sales. Further to these costs, there could be costs for expediting, which is the cost to accelerate the completion and get back on schedule, added manufacturing and purchasing costs, all of which will reduce the expected profit. Some of these events may also differ depending on the product and alternatives that may be available in the marketplace through competitors. Nevertheless, this is a topic worth mentioning, as it highlights worst-case outcomes when you have supply chain failures and have to justify ordering and carrying higher levels of inventory. When making inventory policy decisions, supply chain professionals need to consider the various costs. In the previous lesson, we looked at stockout costs, which is one of those costs. There are others. When you have inventory, you're incurring a cost to hold and store that inventory, which is referred to as inventory carrying costs. Inventory carrying costs can be broken down into three categories. First are capital costs. This cost refers to the money invested in the inventory and the lost opportunity of what it could have earned if it was invested elsewhere. Second are storage space costs. This is the cost of utilities, heating and lighting for the storage area, rent for the building, material handling for moving the inventory from place to place, insurance for the inventory, and taxes. And third are risk costs. These costs include inventory that loses its value over time due to obsolescence, damage, pilferage. You can choose to order large quantities and order less often, but you'll incur the costs of capital, storage, and risk. Alternatively, you can choose to order smaller quantities, but you'll need to order more often. In this case, you'll save on inventory carrying costs, but you'll incur another range of costs, referred to as ordering costs. Ordering costs can be split into two types. First are factory orders. This is the cost to issue orders to manufacturing. These costs include managing the orders, loading, scheduling, closing, expediting. Second are purchase orders. This is the cost to issue a purchase order, cost of receiving the items, cost of receiving the invoice, and its payment. Carrying costs and ordering costs have an opposite relationship. When one is increasing, the other is decreasing. At one point, they'll intersect. That intersection is the EOQ, or economic order quantity, which is the balance between these two costs. And this leads us into our next lesson on EOQ. I'll see you then. As part of managing inventory, supply chain professionals not only need to know when to buy material, but also how much material to buy. So far, we've been discussing the schedule and the when. Now let's review the how much. EOQ, or economic order quantity, is a lot sizing rule used to calculate how much to order. EOQ is not the only rule. There are other methods, but we'll only cover EOQ in this course. The EOQ model establishes an order quantity for a particular item that minimizes the combined cost of ordering and carrying the inventory. Put another way, the EOQ value is established where the inventory carrying cost is equal to the ordering cost. Remember, I said in the previous lesson that the inventory carrying cost and ordering cost have an opposite relationship. When one is increasing, the other is decreasing. Eventually, they will meet. The intersection point establishes the EOQ. Here we have our graph from the last lesson, plotting the inventory carrying costs versus the ordering costs for a particular product. The intersection point is what we're interested in. At this point, the inventory carrying cost is equal to the ordering cost. The blue line above is a plot of the total cost, which is just the sum of the two cost lines below it. When you extend a perpendicular line through the intersection point of the carrying cost and ordering cost and have it intersect the total cost line, it'll give you the lowest point on the blue line, which is the lowest total cost, which in this case is roughly $6,000. If you extend the perpendicular downwards to intersect the x-axis, it'll give you the EOQ, which in this case is 240 pieces. This is telling you that 240 pieces need to be ordered, which will give you the lowest overall cost of carrying inventory and ordering it. That's it for EOQ. I'll see you in the next lesson. When you manage your inventory, you're managing cash flow. When raw material is received into inventory, it becomes an asset. When it goes into production as work in process, its value increases by the labor and overhead that goes into it. The component doesn't generate revenue until it's sold. This can become a financial problem if a business doesn't have sufficient sales and cash flow to pay its workers, vendors, and other expenses. A level of inventory will always be required, whether it be raw material inventory or finished goods inventory on the shelf not yet sold to a customer. There will always be a level of uncertainty from suppliers, internal processes and resources, or from customers, and companies need to protect themselves from the uncertainty and minimize its impact. Inventory is a necessary element for a successful supply chain, but inventory levels need to be managed. As companies outsource and begin to buy from global markets and in turn sell to global markets, the uncertainty increases, as does the lead time of the supply chain. It becomes even more vital to maintain a level of control and stability throughout the supply chain. I think most supply chain folks have experienced the situation of dealing with an item that isn't available when they want it. We're told it's sold out and on back order from the supplier. This happens to the biggest and best of companies, despite all their abilities to manage the uncertainty and minimize it, so that you as the consumer have a positive buying experience and remain satisfied and a loyal customer that will return again and again. Inventory can be managed through internal policies and procedures, as well as programs such as vendor-managed inventory, VMI for short, and consignment inventory. I often get asked, what's the difference between the two? First, VMI is where a vendor maintains inventory at the buyer's location. In this situation, the vendor continues to own the inventory. The buyer pays for the inventory when it's used, at which point the vendor replenishes the stock. The vendor is given access to the buyer's forecast and demand data. The buyer is basically handing over the whole planning, ordering, and management of the product to the vendor. and this is the main difference when comparing VMI to a consignment arrangement. Second, with consignment, the vendor provides product to the buyer and retains ownership of the inventory, same as VMI, until it's used by the buyer, at which time the buyer pays for it. In this arrangement, the buyer retains control of the planning and ordering and continues to place orders with the vendor. This is different compared to VMI, as the buyer does not give up control to the vendor. Each of these methods requires a more collaborative approach, which does not exist with just a straight transactional relationship. The major challenge will be to have the vendor agree to participate in such programs. Another way to manage inventory is a method called ABC analysis. With this method, you can categorize your inventory according to important criteria, such as revenues, lead time, stockouts, etc. This method will assign or classify the inventory into one of three groups according to its importance within the criteria you've selected. As an example, if your criteria is revenues, A inventory items are most important as they have the highest sales. B items are considered less important and have lower sales. And C items are the least important and have the lowest sales. Determining the criteria to use for the inventory classification will depend on the goals the organization is trying to achieve. ABC inventory classification is based on the concept of Pareto's law, which states that a small percentage of items will account for the largest impact. Also known as the 80-20 rule, further clarifies that roughly 20% of the items will account for roughly 80% of the impact within the criteria. Here's the underlying principle. 20% of the items will account for 80% of the impact. The next 30% of the items will account for 15% of the impact, and the remaining 50% of the items will account for the final 5% of the impact. It should be noted that these figures are approximations and not written in stone. If this sounds confusing, let's go through an example and see how ABC analysis works. I'll see you in the next lesson. Here we have some product data and sales information. For this example, I've decided to use the sales dollars as the criteria for categorizing the products. In column A, the products can be listed by an item number or their part number. In column B is the annual sales for each of the items. The next step is to sort the data according to the sales dollars, from the highest to the lowest. The results of the sorting are in columns C and D. Item 8 has the highest sales at $221,873. Item 2, the second highest, at $158,427. And so on to the last item, which is item 3 at $644. You can see that at the bottom of column B and D, the total is the same at $508,300. This confirms that every item is accounted for after the sorting. Next, let's look at column E. We need to cum the sales in column D. In the first position, we only cum the sales for item 8 at $221,873. In the second position, we're cuming the sales for item 8 and item 2 at $380,300. In the third position, we're cuming the sales for item 8, item 2, and item 5 at $428,449. In the fourth position, we're cuming the sales for item 8, item 2, item 5, and item 7 at $458,411, and so on for the rest. I think you get the idea. And it's no surprise that when you reach the bottom of the list and cum the last item, number 3, the total cum sales is $508,300, which is the total as shown in columns B or D. This is another check and confirmation that none of the data has been left out. The next step is to calculate column F, which is the cum sales as a percent. You take the cum sales figure from column E and divide each by the total of $508,300. In the first position, you take $221,873 divided by $508,300, gives you 44%. In the second position, you take $380,300 divided by $508,300, gives you 75%. I think you get the idea. I show you a couple more examples and you can do the rest on your own. As you can see towards the bottom of the list, the cum sales percent reaches 100%, and that should be no surprise. The next step is to assign the inventory classification to each item, which I have done in column G. The first 2 items are classified as A's, the next 3 are B's, and the rest are C's. Now that you've classified the inventory items, what does this mean? What do you do with the information? A items have the highest priority and need to be monitored closely. Their records must be accurate at all times, and the items require frequent review, meaning you always need to make sure that the physical quantity on the shelf matches the quantity displayed in your inventory management system or your MRP. Make sure every piece is accounted for at all times. You may want to consider a monthly review to ensure accuracy. A items should also have a very tight ordering policy and buy only what you need and nothing more. Good example of A items would be expensive raw materials, exotic metals that have lengthy lead times and may not be readily available. The B items are slightly less important and require less management compared to the A items. You should also maintain good records for them. Good example would be more commonly used raw materials. You may want to consider a quarterly review. And lastly, you have the C items, which have the lowest priority. Make sure you have plenty on hand. Buy in large order quantities. It's not important if you lose a few. They are readily available at a low price. You never want to run out. Good example of a C item is hardware, nuts and bolts. And that's it for ABC analysis. If you have any questions and need me to explain further, please send me a note. I'm here to help. Thank you, and thanks for watching. We're almost at the end, so I wanted to say a few words about sustainability and social responsibility. Sustainability refers to meeting the needs of today without compromising the needs of tomorrow, or without compromising the ability of future generations to meet their own needs. It's a bit of a hot topic, a few words that carry a lot of meaning. It deals with climate change, greenhouse gases, CO2 emissions, pollution, protecting the environment, reducing waste generation, energy conservation, water conservation, going green, recycling, renewable energy. In simple terms, we need to leave the planet as we found it, so that future generations, our children and their children, will have a place to live and enjoy their lives. Which is more important, running a healthy business and economy or preserving the environment? Is there a balance between the two? As a supply chain professional, these are the challenges we must face in the decisions we make. We're expected to be responsible and act responsibly. That is, to reduce wasteful practices and meet demand while promoting positive environmental impacts. Because of the internet and social media, we know in seconds what's happening in our city, our country, and even the entire planet. We know when countries are stripping their forests and ignoring the wildlife. We know when countries are overfishing. We also know the working conditions of factories in other countries. The level of information that's available to a consumer is unparalleled. Consumers can reconsider what they buy and from whom they buy. Retailers become concerned how consumer behavior will react. As a consumer, what would you do or how would you feel if the company that makes your detergent is polluting the river where you go swimming, where you go boating or fishing? What if the river is the source of your drinking water? Would you stop buying their detergent? If you did, and so did many others, I'm sure the company would get the message. My comments are just something for you to think about, whether you're a consumer or you're the supply chain expert for the company. As the latter, you don't need your business being impacted by a supplier's poor business practices and questionable behavior. You may be faced with having to make a change to your supply chain. I'll see you in the next lesson. There are various approaches to sustainability in supply chain, known as the 4 R's. Reuse refers to the disassembly of components and their reuse after cleaning, inspecting, repairing, and reassembly. A company I worked for, this was their main business model. Often, new parts are no longer available. Production of new components stopped years ago. Starting up production can be very, very expensive. It may not be practical if you only need a small quantity. Repairing becomes the best alternative and least costly. The business also includes developing new repairs that currently don't exist. the effort becomes to reuse and repair as much as possible to avoid scrapping and disposal. Remanufacturing refers to returning a component or part to the market good as new. Electronics and auto parts are often remanufactured. There's been a few times I've been to my mechanic and he used remanufactured parts, which work great and cost a fraction of the price compared to new. I'm a fan of buying from Amazon and decided on a remanufactured laptop. Had it for a while and it's working great. So far, so good. Reconditioning refers to returning used products or parts to working order, but not good as new. Sometimes there's no need for new or to repair. It just needs some cleanup, lubrication to keep it going smoothly. Recycling refers to the alternate or secondary uses of materials. Bottles, cans, paper are often recycled into other products. Recycling is a huge business these days. Billions of dollars employing thousands. It's amazing to see how many products are out there made from other recycled products. I'll see you in the next lesson. Sustainability in the supply chain can come in many forms. As an example, packaging materials often ends up in landfills. Next time you buy something online, look at the packaging when it arrives. Companies can significantly reduce packaging waste by using alternate materials and reducing the amount of packaging. Another example, a manufacturer who will remain nameless decided to reduce the size of their plastic bottles used for liquid detergent by reducing the water content of the liquid to make it more concentrated. Eventually, customers accepted they could achieve the same results with about 50% less of the liquid detergent. The overall impact was huge. Transportation costs were reduced due to the lower weight and volume, resulting in lower rates. Packaging and warehousing costs were also lowered due to the smaller container size. Smaller packaging also allows retailers to better utilize store shelving. Using less shelf space on one product allows more space for another. Something so trivial as using less water ends up providing far-reaching benefits across the supply chain and also helps the environment. Remember, you're using less water and lowering emissions for reducing transportation. More on sustainability in the next lesson. I'll see you then. Sustainability drives innovation and to think out of the box. I'm going to share with you a case study on how a hotel chain embraced sustainability, developed a sustainability program, and rolled it out across its many locations. It all started with the hotel company trying to sort out a problem. Through its regular course of business, the hotels had to dispose of various defective and damaged items, such as bedding, linens, furniture, uniforms. Each location was left to do it on its own. Eventually, upper management started to take notice of the effort involved and the cost that was all going to waste. It was also being recognized that sustainability is playing an increasing role in determining consumer preferences. Remember, I mentioned earlier, when you're doing the wrong thing, consumers will take notice and may not buy your product. In the case of the hotel business, if consumers see you're using wasteful practices, they may decide not to stay with you and go to another hotel. Businesses such as hotels need to respond to the changing landscape and consumer behaviors surrounding our limited natural resources and the increasing cost of energy supply. Avoiding these issues and ignoring the long-term consequences can be detrimental to the business and viewed as a failure to adapt. I know I'm repeating myself as I mentioned this earlier in the section. Sustainability and environmental responsibility can take on many forms, such as recycling, reusing, waste reduction, energy conservation, water conservation, use of renewable energy, going green are key areas to tackle. Here are some of the strategies the hotel had available and implemented. The different locations can partner with charitable organizations or local charities to donate the unwanted and defective items. Through the charities, the items can go towards supporting community projects, including the homeless, women's shelters, orphanages, homes for the elderly, and drug rehabilitation centers. Items can also go towards supporting victims of hurricanes and other natural disasters. Even unclaimed articles from the hotel's lost and found can be donated. This is a great way to bolster the hotel's image in the local community while helping others in need. These days, many businesses have some sort of recycling program in place. Paper, bottles, cans, plastic tend to be the main items being recycled. Depending on your business, recycling can also be expanded to include batteries, certain liquids, metals, to name a few more. A simple recycling program in guest rooms that removes paper, plastic, and other recyclables from the waste can significantly reduce the hotel's disposal costs. Manufacturing new products from recycled materials uses less energy and generates less water pollution than manufacturing from virgin materials. Overall, recycling is good for the economy as it provides the raw materials to make new products, creates jobs, reduces waste, saves energy, and preserves landfill space. Recycling is also good for the environment as it requires less energy, uses fewer natural resources, prevents global warming, reduces water pollution, and protects wildlife. The hotel company used its existing recycling program to implement further initiatives supporting sustainability. The hotel created an incentive program to encourage staff to participate in environmentally friendly practices. They increased awareness through education programs for staff to turn off lights and turn down heating or air conditioning in unoccupied rooms, close curtains to reduce the need for air conditioning, or open curtains to reduce the need for heating, check and report leaking faucets and toilets, and check for and turn off unused hotel equipment that may be left running. Staff also encourage guests to reuse linens, both towels and sheets, and only replace them upon request instead of daily. Water conservation is another area the hotel looked into for their sustainability and environmental initiative. To reduce water consumption, they installed low-flow toilets, faucets, and shower heads. Water from kitchens, bathroom sinks, showers, and laundry can be recycled for reuse in gardens and lawns to limit freshwater usage. Energy conservation is another area. They installed energy-efficient light bulbs and energy-efficient appliances. They switched to LED light bulbs in guest rooms, lobbies, and hallways. They replaced outdated lamps with newer models that reduce energy use and improve light quality. They installed occupancy sensors or timers to conserve energy in less frequently used areas, such as hallways, outdoor areas, or public bathrooms. These devices turn on the lights when occupancy is detected and turn them off when occupancy is not detected. These are just a few of the many low-cost improvements that can be made to yield huge returns in a short period of time. The hotel also looked into implementing other eco-friendly changes through use of recycled materials used in mattresses, fabrics, upholstery, wallpaper, flooring, and carpets. In their restaurants, they used table placemats and bread baskets made from recycled material. And the list goes on and on. I think you get the idea. Lots of ways to save and do your part for the environment. And the best thing is, you make an improvement and it gives you multiplier savings and benefits. And investments quickly pay for themselves. In this lesson, I want to share with you further examples of the innovations I've come across that are directly linked to sustainability. In some cities, areas are so congested that space isn't available to traditionally park vehicles or erect traditional multi-level parking garages. When you have limited space, going vertical and being compact is a great option. And here are a couple of examples of vertical parking lots. Where you would normally fit one vehicle, you can now accommodate upwards of 4 or 5 or more. These automated parking lots come in many shapes and sizes and are called by various names such as robotic parking garage, car parking system, automated parking facility, automated vehicle storage and retrieval system, mechanical parking, to name a few. Beyond the space savings, other benefits can include added protection for the vehicles against break-ins, theft, dents and scratches caused by other vehicles. Plus, these units can be fully automated, so you don't need an attendant. The concept has been around for many years, and as populations continue to grow, along with cutting-edge technologies, we could see more of these systems in use in our own neighborhoods. Looking at Figure 1 on the left, I'm guessing that most of you have seen or used something like this. It's a keycard locking system. You tap or swipe the card, and it unlocks the door. It replaces the traditional lock and key. The concept and technology is widely used these days. I've seen and used it many times. As an add-on to this technology, once you enter, there is a keycard slot inside the room where you need to insert the card. See Figure 2 on the right. Once inserted, you can turn on the lights. Otherwise, the lights won't turn on. If you pull the card out of the slot, the lights eventually turn off on their own. This is a great energy conservation feature and works well in hotels, as it prevents lights being left on in vacant rooms or when guests are out. If anyone has ever stayed at a hotel, you most likely saw this hanging on the door. It serves a similar purpose as the Do Not Disturb sign, in that you are sending a message to the hotel staff. In the past, housekeeping included frequent replacement of towels and sometimes linens. In order to conserve energy and water, guests are encouraged to reuse and hang this sign outside the door to let the staff know not to replace the towels. The bottom line, if sustainability is to work, everyone needs to contribute and do their part. Businesses need to play a major role when it comes to the environment. They may need to change. Change can be business processes, manufacturing processes, mindsets, culture, to name a few, all of which may have been in place for many, many years. For some, it can be a struggle and uphill battle, but necessary. So where do you start? To be serious about sustainability, it all starts at the top. A business needs to consider making sustainability a strategic priority and a core value. The business needs to be able to demonstrate corporate social responsibility. And the best way to do that is to adopt a sustainability key performance indicator, a KPI, to define, measure, and understand its environmental, social, and financial performance. Most businesses will have financial indicators, but how many also measure their environmental and social performance? I don't think many do, but they're starting to. I'm sure when it comes to the economy and climate change, there's going to be varied opinions, many valid and strong arguments for either side. This all assumes that one side needs to be sacrificed in order to be successful on the other. Ideally, you want to achieve success on both. That being said, I'd like to introduce you to the triple bottom line. This is what it looks like. It's also referred to as the 3 pillars of sustainability. The triple bottom line was developed in the 1990s. It emphasizes corporate social responsibility and requires organizations to consider social and environmental impacts, along with the need to make profit. Pressure from society as a whole is growing, and businesses want to appear green, but not all are willing to sacrifice profits. In turn, the triple bottom line highlights an organization's responsibilities towards society and the environment. It's a measure that provides accountability for the overall effect of the company's business practices. It focuses on 3 measures called the 3 Ps: people, profit, and the planet. People is a measure of how socially responsible an organization is throughout its operations. Businesses need to focus on the community, social surroundings, internal resources, and its commitment to people. It's important to distinguish between an organization's shareholders and stakeholders. Traditionally, businesses have favored shareholder value as an indicator of success. Organizations strive to generate value for those who own shares of the company. As businesses start to embrace sustainability, they've shifted their focus toward creating value for all stakeholders impacted by business decisions, including customers, employees, and the community. Next is profit. This is the measure of the financial performance and profitability of the business. Success is defined by how much profit is generated for shareholders. Key business decisions and various corporate initiatives are generally designed to maximize profit while reducing costs and mitigating risks. And third is the planet. This measures how environmentally responsible a company has been. It's concerned with the location, the area, city, or region in which the company is located. They must ensure that their operations don't affect the environment adversely. This measure emphasizes business practices that cause the least damage to the environment. While businesses have historically been the greatest contributors to polluting the environment, which has been a driver of climate change, they also have the power to push for positive change. Business leaders are beginning to recognize their responsibility to do so. This effort isn't solely on the shoulders of the world's largest corporations. All businesses, no matter the size, have opportunities to make changes that reduce their carbon footprint. Let's go over some triple bottom line examples that businesses are adopting. I don't know about you, but I've noticed these changes. Stores are phasing out single-use plastic bags. They're being replaced with renewable or recyclable options. I've noticed this at grocery stores. Restaurants stopped giving you a plastic straw. Now you get a straw made from recycled materials. Businesses that use plastic packaging are switching to alternate materials that are reusable, recyclable, or compostable. Supporting local communities and charities through donations. It can be donations of money, clothing, canned food items. Companies are coming out with policies for the benefit of and to protect employees. Here's a few I've come across. Conflict of interest policy, anti-corruption policy, diversity and inclusion, code of ethics policy, health and safety policy, whistleblower protection, disconnecting from work policy, workplace violence and harassment policy, fragrance policy, and there are many more out there. And that's it for this section. If you have any questions and need me to explain further, please send me a note. I'm here to help. Thank you, and thanks for watching. We're almost at the end of the course. It's been a great journey teaching you, and early congrats on getting this far. The next 4 lessons are very important. They are exams with sample questions and problems. I hope you find the time to complete each, especially if you plan to go for certification. The practice tests will give you a very good idea of what to expect on the actual exam. A few personal comments before you begin exams 1 and 2, which are the multiple choice exercises. Read each question carefully and thoroughly. Take care to avoid assuming information not given, as well as assuming you know what's being asked without reading the question completely or second-guessing the question. Effort has been made to avoid misleading wording and to provide sufficient information for each question. Choose the best answer from the choices given. Don't look for hidden tricks. The questions are designed to test your knowledge, not to trick you. For each question, one and only one of the choices is the correct answer. There is no time limit for this exercise, so take your time, but keep in mind there is a time limit during the actual certification exam. That's it for my speech. Good luck. Now that you've mastered the vocabulary, let's see how you do in this exercise and how well you understand developing a production plan. You can download and use the blank template I've attached for your solution. Feel free to go back and review earlier lessons before you get started. Take your time and take as much time as you need. There's no time limit. If you're looking for the solution, keep watching the video to the end. I've also provided the solution in the Excel attachment for you to download. Look at the tab called Solution. Good luck. This is a very good practice question that you can expect something similar on the exam. It's testing you on multiple concepts that were taught in the course. All the information you need is provided. Take note of the information below the chart. You'll need it to answer correctly. Again, as mentioned previously, you can download and use the blank template that I've attached for your solution. Feel free to go back and review earlier lessons before you get started. Take your time and take as much time as you need. There's no time limit. If you're looking for the solution, keep watching the video to the end. I've also provided the solution in the Excel attachment for you to download. Look at the tab called Solution. Good luck. Welcome back and congratulations. You've completed the course. I want to thank you for taking this course. I appreciate it very much. I hope you learned a lot and I was able to teach you something new about supply chain. This course is just another step along the journey, which is far from over, so stay tuned for more. I am always looking for your comments as well, so please reach out to me. I look forward to meeting your needs and making improvements. I think it is a win-win situation for both of us. Without your eagerness to learn, I would not have this great opportunity to teach your bright minds. I thank you for the privilege to teach you. If you decide to rate this course, I hope it is worthy of a 5-star. Remember, comments are equally important. As an instructor, ratings are my motivator to strive for better and greater heights. Thank you, and I will see you soon.